Okay, shall we start? Today, I would like to invite our guest speaker, Mr. Saharat Petpraprasoet. He experienced in biomedical engineering. So the topic that we're gonna have the lecture today is the calibration and verification of medical devices. Firstly, I would love to recommend a little bit about our speaker today, Kun Saharat Petpraprasoet. He is the uh, engineer right now, and he graduated from biomedical engineering, Rangsit University. His work experience, he was the product specialist at TREATMED Company Limited, and now he is a sales engineer at TREATMED Company Limited. For the advanced training, he has a best practice in infusion devices analyzer, Fluke Biomedical, best practice in patients simulator, Fluke Biomedical. He is a best practice for the future monitor testing, NIBP and test optimization, ventilator tester, incubator, radiant warming analyzer, also ISO 14644 clean room technology, best practice for radiation quality measurement, evaluation, and certainty for medical devices. So this is our great opportunity to welcome Kun Saharat to give our knowledge his knowledge for our participant for the calibration and verification of medical devices. So please welcome Kun Saharat Petpraprasoet from TREATMED.
Hello everybody, do you hear me?
Yes, perfectly.
Okay, so first of all, I will present to the company profile first for the how we do in Thailand, and then in next session I will provide for the theory of the electrical safety, and then how to the calibrate the patient monitor. This is the section. I will demonstrate. I will demonstrate for the how to the calibrate the medical device to you. Okay, so start. First, we are a treatment company limited from the Thailand. The treatment are the under the Food Healthcare Solution. The Food Healthcare Solution under the 40th in the USA. The 40th, they have many branches of the business. The Food Healthcare Solution is the one business in the business group. For in Thailand, we are the uh, distributor for the Food Healthcare Solution. In Thailand, we sold many products of the calibration device in Thailand, and we have a good relationship with the university and the hospital and the government place. And now we will show you for the our product to show in Thailand. This is a video for the our product. I will show you. This is electrical safety, and this is a defibrillator analyzer, and this is electrical surgery analyzer. And this one is incubator and radio warmer analyzer. And this one for the electrical safety for the all medical device have electric. This one is the patient simulator. This one you can test all patient vital sign monitor with this device. And this one is the ventilator analyzer, and also can test a vaporizer. This one is the reset for the scattering X-ray. This one is the dosimeter. It's a real-time dosimeter in the X-ray room. And this one is the X-ray calibrating, and we can measure for the QVP dose rate in the X-ray machine and also a CT scan. And this one is the new medical device for the efficient tester. So we are the full healthcare solution for the this one. All of this I provide and sold in the Thailand for the BMS. BMS is a biomedical standardized for the medical device, and the X-ray tool for the calibration for the X-ray, CT, and the phantom mammography and radiology. For this one is the real-time dose monitoring, and we also use in the cat lab in the hospital, and we can see the dose for the real time, and this for the X-ray survey for the when we expose the X-ray, we can use this device for the measurement for the X-ray in the X-ray is tester and outside of the room of X-ray. So this is the motto of the treatment solution for measurement. We not only sold the medical device calibrator, we sold the solution and like a consultant for the customer, for the client, and the customer when we start the issue in the problem for the calibration, we can solve the problem for them. So in the past, we arranged the seminar workshop with the full healthcare solution, the calibration for medical device and ventilator and vaporizer. And also I cooperate with the university when the university they want to the special section for the calibration. I will arrange with them, and also this is a workshop with the students from Ragabang University Biomedical Engineering. Yes. And the next, this is a new software for the Fruit Biomedical. This is a Once QA software. You can try for the Once QA to scan this. And then this is a reference from the treatment plan. Okay, this is the first session is finished because for the presented for the company, and then we come to the electrical safety theory. Okay, come to the electrical safety theory. For the all medical device in the hospital is use electric, right? So it's necessary to the electrical safety testing first and then use it, because the medical device in the hospital must be safe. So in Thailand, we consider about the because the electrical safety can be the patient can be harmful and it's not safety. So the first medical device, the first thing after we inspection for the medical device, then we do the electrical safety and then performance testing. For the electrical safety in Thailand, we use the two standards and one guideline. The first in the first this slide explain about the importance of the electrical safety. So in diagram in the top, this part is the power supply and the power supply outlet in the wall. In Thailand, we use the 230 volt and 50 hertz. And then when you plug in the medical device, this is a line, ground, and neutral. With the line, the current comes through the medical device. The medical device we can use with the current. So when the medical device use the medical device, all of the medical device they have a leakage current, right? The leakage current, if they have the leakage current, the leakage current is come to the ground and come through the ground of the building. It's safe, but it's not. The medical device is not ground. The current is can be come through the human. The human is when the current come to the human, the patient is the harmful and the pain. Yeah. For this diagram is the easy diagram for the current, and it explains to you about the when the medical device is the 10 ohm used with the power sourcing for the 230 volt, and when we use the is when the current come to the medical device, when the rate of current is come to ground. In the left side is a ground. Is ground is the 0.5 ohm. Mhm. And then separate for the current into the human. The right side is the resistance of the human, and all of this come to ground. If the medical device is not have ground, the current is directly come to the human and come to ground. It is it made the patient is a shock, electrical shock. Yes, it is a impedance of the ground of the medical device. This slide will show you for the type of the electrical shock. For the left side is the macro shock. The macro shock is the more current, is more than around 1 milliamp and come through the left side and then come to body out to the right side and come to ground. This is for the macro shock. Is more current come to the human and make the human and burn the skin and shock and carry a fibrillation. This is the Microsoft. This is the common for the all of electrical device is the microshock. And we concern about the for the medical device, we concern about the microshock. The microshock is the less current in the medical device and come through the human and pass the heart and come to the ground. It can be the damage the heart directly and can make the patient is die directly. This is a microshock. This is we talking about the raised current about the 500 microamp, 600 microamp, less than 1 milliamp. allow that. So this is a current for the current level for the uh, possible effects of on the human body. For the 1 milliamp is the you see the green is a smile because the 1 milliamp is not dangerous for the human. Depends on the age, depends on the distance skin, depends on the tall, depends on the weight for the human. And for the 5 milliamp to the 16 milliamp, this is a red go current. When they have touched the medical device and then sense and then sense the electron, oh, it's shocked. This is a red go current. Allow the 5 milliamp to 16 milliamp, and then 17 milliamp to the more than 2000 milliamp. This is extremely for the is dangerous for the leakage current for the medical device. This is made for the extreme pain, respiratory arrest, death, and fibrillation. This is happening from the more than current. So this is rate current versus frequency. So do you see in Thailand we use the 230 volt and 50 hertz. For the 50 hertz is the AC current. The AC current is the made you the pain, made you shock because the frequency is for the threshold of the frequency in the less current it can be shocked. You can see in the graph in the red line. The red line is a threshold of sensation. In the red current as the 1 milliamp, 2 milliamp, we can shock at the 50 hertz or 60 hertz. This is the danger of the frequency in the human. So this is protocol, the basic and memory protocol when we do the calibration device in the hospital. In the first step, we are inventory and identify the medical device. When we inventory and identify the medical device successful, and then we planning to the calibrate. Okay. Okay. For the this is the diagram for the show you the flow chart of the protocol in the when we do the calibrate medical device in Thailand. The first thing is the selection of the trace, and then the visual inspection, and then to come to the electrical safety. For the first topic for the electrical safety is the protective earth resistance, and then measurement for the leakage current, and then come to the insulation resistance. When this part in the 1, 2, 3 in the 3 items it is part and come to the functional testing and report for the when we do the current, and the final is evaluate for the medical device is the can be used and not used. For this is the factor of risk for the electrical safety. This is the in the picture you see in the you see for the power cord is the damage. It can be burn and electric in the wall and can be shot and burn. This is a not safety. This we not recommend for the use this power cord. So this is the multi-socket outlet. For the IEC 60601, that one we call that the multi-socket outlet. This is a extension cord. This is a UPS power supply. For this device is normally in Thailand they use the extension cord for the extend the range of the power cord. And the extension cord is the we recommend for the is a good ground in a good power cord. because the extension cord is not standard. It can be damaged for the medical device. So this is we not recommend for you this picture because we use the plug and power cord is a lot. It can be to do this picture because when we use a lot of the power cord in the extension cord, it can be uh, bring the current, more current, and can be damaged and burn. Uh, this is the risk of the medical device when we use more than one. Yes, in the website is the complete the system of the medical device. For the website is the patient they use the ECG machine, and also they use the electro surgery unit in a together. And this is a complete system when the when the leakage current come to the ECG machine and come to ground and come to the ground system in the building, and also electro surgery unit, electro surgical unit. When we use in the complete system, when we have the leakage current and come to the cloud of the medical device and come to the cloud of the building, this is the ideal and normally complete system in the hospital. And in the right side, when they use the ECG machine, and ECG machine is the cloud connection is broken. The cloud connection is broken, and is leakage current is stay on the skin when I touch the patient, stay on the patient. And when we use the ESU, the ESU is a complete system attached from the patient. The current is on the human. It come to the apply part for the ESU, and then come to the ground of the building. This this picture is can be made the patient is shocked because the current, the electric current is stay on the human. When we attach the concrete, the medical device, and current is throw past the human and come to the ground. It can be the made the patient shock for the electric. This is a non-recommend uh, system. Okay, the standard and guideline in the Thailand, and almost standard and guideline in Thailand, we use the IEC, and the two standard is the IEC, and the one guideline is the ECRI. For the IEC, we use the two standard for the IEC. The first part, we use the IEC 60601 that one for the acceptance test. In the first time testing, when we use the medical device, we use the IEC 60601 that one. And then when we use the medical device many time, and 1 year, 2 year, and around that, we change the electrical safety standard to the IEC 62353 for the recurrent test and the test after repair of the medical device. We use the 62353. And then almost hospital in Thailand, we use the ECRI guideline for the medical safety. Oh, okay. This is a theory of the IEC 601 60601. That's one. For the first, we we must know for the class of the medical device and type of the medical device. For the class of medical device in Thailand, we use or mostly we use the we made the two class of the medical device. Class one, for the class one is the normally medical device in the hospital is a class one because the class one is the grounding resistance. The ground is the connect to the chassis part of the medical device, and when the medical device has a wicked current and can be come to the ground and come to the ground building of the hospital. This is the class one. Must be ground. This is a picture from the IEC 60601-1. It explains you about the diagram for the medical device in the class 1. For this part, number 9, for this part, number 9 is the main part for the switching power supply. It comes from the high voltage from the building and from the from the building. This is a 230 volt and come to the main path and then control to the number 8. Number 8 is the secondary circuit. For the secondary circuit, it is the isolate from the main part. Is a protect the patient. It cannot be the shocked by electricity. This is the diagram for the IEC 601 network. 2 is the class 2. The class 2 is the is in Thailand is the is not mostly in the for the medical device. For the class 2, the class 2 is the we call the double insulation because the in the chassis is the insulation of the safety is not the conductive part for the outside, and then in the inside for the inside is a primary main is the this is a insulation also insulation for this class is the most safety for the electrical safety in the for the electrical safety for the this is a class 2. For class 2, this is the again from the 60601-1. You can observe this for number 9. The number 9 is for insulation for the main part of the medical device. This is insulation, basic insulation and insulation for the protect the current, get current from the medical device. This is a class 2. The class 2 is you can get the class 2 and the class 2 is not have the ground because the main part is that they have the insulation for protect the leakage current. For the applied part, the applied part is the everything can be the attached the patient. We call the applied part as the ECG, as the ultrasound probe, something like this is a can attach the patient. Is the we call the applied part in the 60601-1. The for applied part we separate for the is for the type is the T type. For T type is the you can see the in the picture. The picture can show you for the type of the applied part in the medical device. The left side and right side is the same, and but not the same for the especially in the for this symbol in the picture. Okay, for the B type, B is the body, The applied part can be attached the human, the patient, and when the electrical shock is not damaged, not dangerous for the patient. And the next for the BF is the body floating. And the body floating is you can observe that the picture in the human and the rectangular for the cover for the of the human. The BF is the body floating. The body floating is the when you use the apply part to attach the patient, when the concept when the electric current come to the patient, it can be damaged, pain and it will cause shock to the body directly. Okay. And the last, the CF type. The CF type is the cardiac floating. The cardiac floating is the apply part is the invasive in the patient and the attack from the nearby the near the heart, something like this. It, when the when the electric current come to the heart and come to the apply part in the patient, it can make the patient is shocked and die. Yeah. For the left side and right side is different for the it is different for the disable. Disable is the defibrillation proof. For the defibrillation proof is the when we use the medical device and defibrillator together, it cannot be done from the defibrillator because the defibrillator is the high voltage, high current, and high energy. For the defibrillator can be can be damaged when you use a medical device. It's not visible, not have visible. It can be damaged when we use we have the visible. It can be used together. So this is the applied diagram for the more understanding to you. Okay, this is the tolerance for the IEC 60601. That one when you testing the cost safety in of the medical device, we separate it in the B, type BF, type CF type. This, this is a number of a tolerance is not exceed the number in this table. For the example, for the touch current, the touch current is the electric current. It comes to the chassis of the medical device, and when we touch the chassis of the medical device, this can be shocked. For the touch current in the VF type, NC is the normal condition. Normal condition is the right, ground, and neutral is the complete. Is a complete. And NC condition and the touch current is not exceed 100 microamp for the example. And SF3, SSE is the single fault condition. For the single fault condition is the not complete the system when we use, such as the ground broken, Newton broken, something like this. Is for the tolerance is the 500 microamp. It's not exceed 500 microamp. This is a table from the IDC 60601. That one you can use it for the acceptance testing when you uh, meet the first when you meet the medical device first time. Okay, this is explanation about the SF3. We from for this from the IEC 60601 that fund in the support 4.7 in the explanation for the single fault condition of the medical device equipment. Okay. Okay. So we started the second section for the protective for the do the electrical in the device and I will camera to demonstrate. Wait a moment for the switch camera and set up the camera to
Hello คุณสหรัฐ I think that right now
the
your internet was
do the electrical safety
gone
in แป๊บนึงนะครับเดี๋ยวผมขอ
because we didn't see any share slide before ค่ะ ค่ะ maybe your internet having unstable so okay the participant please wait because of internet unstable so some technical problem
Uh, actually, I close the camera first for the set up
okay
the camera.
yes so you I think that you better close the camera first and then just like a presentation and after we done for the lecture and for the demonstration part we later on the camera ค่ะ
Okay. Do you see the camera?
see the camera yes
Yes.
so this is will be the demonstration of the device part right
Sure. For the start, I will plug the power cord for the electrical safety first. Okay. Sorry for technically. Okay, sure. Shall we start for the demonstration for how to the electrical safety testing? Okay, the first step when we use the electrical safety device analyzer is use the red line to the zero the red line first because it's interrupt for the system when you measure the protective earth resistance. Okay. And then we use the power cord for the medical device and plug into the medical safety analyzer. Yes. And then for the red wire, we connect the protective earth in the behind of the medical device. This is the for this connection is for the class 1 of the medical device. For the class 2, it's not necessary to be the measure for the protective earth. Okay, sure. This is the stand of the protective earth. Mhm. This is the resistance of the protective earth. 0.67 around that. This is
เออ
the protective earth from the medical device.
คุณกหรัตน์คะ we cannot see the screen of the device. Can you show it closely, please?
Okay, we will zoom. Can you see the display of the electricity analyzer?
Yes, we can see.
Okay, this is value for the when we when we measure the protective earth. So this value is the 0.66. Uh, when we compare the standard, when you compare the standard for the IEC 60601, that one we is not exceed the 0.2. This is not part for the IEC 60601. And for the next IEC 62353, not exceed the 0.3. For this value is not passed for the IEC 62353. And the last for the ECI guideline is not exceed for the is not exceed 0.5. The for this value is not exceed is not part for the ECI guideline. This is for the example when we measurement the protective earth. And the next is we will show you for the how to the uh, measurement for the enclosure leakage current. The enclosure leakage current, we come to the function. Okay. I will change the standard to the IEC 60601-1 and then come to the leakage current. And then for the electrical safety analyzer, we will push for priority first. Yes. And select the enclosure. We for this is a leakage current from the medical device. This value is the 0.2 microamp, and we compare for the this condition is a NC. NC is the normal condition. The normal condition is the polarity normal, right, and strong is normal. The neutral is a closed. The closed is mean the closed circuit. The closed circuit is a short circuit, and earth is a short circuit. This is a normal condition when we measure the enclosure leakage. The normal condition is when compare the IEC 60601 that one, the 60601 that one they recommend is not exceed the 100 microamp. This is a value when we measure the enclosure in the normal condition is the 0.2 microamp. This is the plus. This. And then open the neutral. Open the neutral. We put the neutral change to the close to the open. Okay. For this part, we must open the medical device also. And for this is the value when we leakage current from the SFC condition. The SFC is a single fault condition. The single fault condition in this case is the I open the neutral is the open the circuit of the neutral. For the open neutral for the IEC 601 that one they recommend not exceed the 500 microamp. This is the value from the open the neutral. This 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 is a pass. Okay, and next open the earth. Open the earth. When you open the earth is the SSC condition in the 601 that one. The 601 that one we recommend they recommend not exceed 500 microamp. This is a value for the when I measure the enclosure and open the earth. This is the value 167 or approximately microamp. This is a pass because not they not exceed the 500 microamp for the enclosure. And next, uh, in this slide show you when you meet the apply part is cannot be attached. The apply part cannot be attached. The electrical analyzer we use the aluminum foil. In the we use aluminum foil in the class 2. In class 2 they we can attach the of the lead wire in the connecting of the medical device. We use the we use the aluminum foil to help the conduct the leakage current to the aluminum foil, and then we measure from the aluminum foil. Okay. Okay. Next is the pressure leakage current. The pressure leakage current is the we measure the applied part. The device is the attached patient. For this medical device is the patient monitor. I will attach the ECG lead on the top of the electrical safety analyzer. then connect the connector for the adapter to connect the rig. Okay. We will connect the rig, complete rig. And next, we going to the apply part for the measure the apply part leakage. And to use, we can select the number of the rig when do the measurement. And in this part, we select all of this because we connect all of this. Select. Okay. For the normal condition of this, the pressure leakage. For the normal condition, for the ECT is the type of the ECT is the CF type. You look in the table for the type CF. For the NC in the pressure leakage current, the NC is the normal polarity, cross neutral, and cross earth. And then this is the measurement value from the ECT applied part. This is the 2.1 microamp. In the table, the IEC 60601, that one, they recommend the not exceed the 10 microamp. This part is part. And next, we will do the for the SFC condition. The SFC condition is the new open the neutral. For the SFC condition is the I microamp. When we open the neutron is the value for measurement is the 2.8 microamp. This is passed. And next, open the earth 4.7 is passed because the all of it is not exist 50 microamp. Yes. This demonstrates for the uh, electrical safety in the medical device for the class 1 and the applied part is the CF type of the patient monitor with the patient simulator. Okay. Next, this is the patient simulator for do the performance testing for the vital sign monitor and NIBP, ECG recorder, and oxygen saturation. Okay, I will show you the display in the patient simulator. Um, อาจารย์สนิ we will set up the camera for the patient simulator first, and I will close my camera first for the setup first.
โอเคค่ะ
ขอบคุณครับอาจารย์
so he's setting up the camera for the patient simulator. So while the speaker setting up the system for the demonstration, in the case if any of participants have the questions, so you can type the questions and then we're gonna answer you later.
Okay, I will set up the camera for the query display. Do you see our display? And then when we set up the patient simulator, we connect the ECG read. For the ECG read, we observe the color and the uh, character of the read as the RA, RLL, F. Okay, so now we have an assistant for the holding the camera to the to the to the show you for the demonstrate of the patient simulator and patient monitor. Okay, so now we connect the ECG already, and then connect the SPO2 module from the patient monitor, and then we set up the value for the simulation. Okay, for now, in the ECG, we use the wave group. The wave group is the normal standard rhythm. It's a normal ECG wave. The normal ECG wave. Yes. And then set the heart rate. The heart rate. So normally in Thailand, we set the heart rate depend on the end user use. As the for the normally patient meter, we use the 60, 80, 100, and 120, something like that. And in this case, we will set 80 BPM. Mhm. Okay, and then when we set the 80 BPM, and then we compare this simulation value to the and the patient monitor. Okay, let's come to the patient monitor. The patient monitor show you about the 80 BPM. It's the same like a patient simulator. This this part for the ECG simulator, ECG value is the task because not error in this case. The error in for the error and the tolerance, we use the ECI guideline. The ECI guideline we recommend is plus minus 5% of the heart rate. Plus minus 5% for that. Okay. And next we set up the heart rate to the high level. I will set up in the 120 BPM, and then we look at the patient monitor display, and after that, okay, this is a value same like patient simulator. Is the 120 is passed. This is for the calibrate the heart rate in the patient's monitor. Okay. In the next In the next, we move to the SPO2 calibration. The SPO2 calibration, we set the value depend on the end user use as the 95, 97, 98, 99, and 100. In this case, I will set in the 97 for the power amplitude. The power amplitude, the full biomedical they recommend for the 3%. The 3% is the uh, efficiency value when we test the SPO2. And then next to the type, the type is the we must select the brand because the SPO2 is not standard uh, for the metrology method because it is not respect for to the SI unit. The when we test the SPO2, we must choose the type and brand is the correctly. In this case, we use the new core band, new core band, and then we set other value in the 97%, and we compare to the patient monitor. Okay, and go next to the patient monitor. The patient monitor is the show you about the 98%. 98%. The, for the tolerance of the SQ2, when we testing the tolerance, we recommend compare with the spec and specification of the patient monitor and the data sheet. For the new core, we use the tolerance is the plus minus 3% of the SQ2% value. This this indicate is passed because the for 97% plus minus 3 is around the 94 to the 100 is a pass. And then next we try to the select the wrong band. This is I select a wrong band Philip, and then we come to simulate for the 95 and observe that the display of the patient monitor. Okay, its value is the same because the band is nearly technology. It, it can be happen. Okay, so this is the SPO2 testing, and next we calculate. We do the respiration. Respiration for the respiration of the patient meter. They are measured from the ECG lead. The reference lead is the LA. Some patient meter in reference is LL. We can change in the calibrator device or the simulator device. And next, we are setting to the rate to the 15 breath per minute. And observe and observe the value of in the patient monitor. Okay, this come down to the 15. It's the same like the simulator. This is the path. And next, we move to the NIBP. The NIBP, we have the two steps for the calibrate the medical device. The first step is we do the calibrate in the dynamic pressure and then static pressure. For the NIBP, I will show you connect the NIBP to the patient monitor. Okay. So sorry, we are the find some the uh, necessary for the connection of the NIBP. Okay. Now we start for the NIBP simulation. So the first we set up for the systolic and the diastolic. For the systolic is the heart contract and for the diastolic is the heart contract. For the systolic we set the 170 and the diastolic we set the 80. And then We push start from the pressure monitor. Okay, and this is the value from the simulator. We simulate for the 120 and 80, and the display of the pressure meter show you for the 116 and 69. For this part, it for the ECI guideline is we not show you about the tolerance of the dynamic pressure because the dynamic pressure is not standard for the testing. Is for the national maturity they not recommend for when we do the calibration they not recommend the dynamic, and for the verification we recommend for the dynamic testing because the for the real situation we use the dynamic testing for the patient. And then I try to the in the simulation. Uh, they have we have the envelope shift. The envelope shift is the value for the shift to the sensitivity of the sensor in the patient monitor. Okay, next for the static pressure. Okay, for the static pressure, we test about the leak test, pressure relief test, pressure source. For the leak test, it the we do for the rig rate in the patient monitor. But the for the static pressure, we will entering for the service mode of the patient monitor first because the when we test of this, it can be read a lot because the solenoid valve in the patient monitor is always is open. We must entering for the service mode because the close the solenoid valve first. Okay, for in this case, we cannot close the valve because the pressure meter is not. We must have the password for the enter enters to the service mode, and I will explain for the how to test first. For the rig test, this test when we enter. For the rig test is the we must set the target pressure too high because the when the high pressure is not reached, is a lower pressure is a not reached also. Okay, uh, we recommend set up the target pressure is the maximum of the pressure in the pressure meter can be received. The leak rate is the for the ECI they recommend for the not exceed the 4 millimeter mercury per minute. And next pressure relief. For the pressure relief is the good function for the safety in the patient safety. The pressure relief is the how the monitor patient meter when we get the high pressure, we can cut the pressure relief off because the save the patient. We recommend the target pressure for around 330 millimeter per millimeter per mercury because the pressure meter is not be pump the pressure too high. Okay, and next this is the pressure source. The pressure source is the calibrate the accuracy for the pressure sensor because the pressure source is the static pressure. When we do the calibrate and report the static pressure in the pressure source, and then the step of the target pressure,
Kun
we
Saharat ka, may I disturb you? Maybe you can move the camera close to the screen because we cannot see the screen right now ค่ะ The screen of the device.
oh the skin of the this okay. Okay, okay. Do you see the screen? Um, okay, okay. And when we set the target pressure from this, we recommend that 120 and the next 120 and next 150 and next 80 millimeter mercury for the static pressure. Okay. So okay, this is the demonstrate for the how to do the calibrate of the vital sign meter since electrical safety and performance testing from the medical device. Okay, this is complete for the demonstrate. And when we have a question, we will type of the asking me right now.
Okay, ค่ะ we have some question from the chat box. They ask how regularly need to do electrical safety check and other calibration of the machine.
Yes.
How regular need how regularly need to do the
Uh,
electrical safety check.
for the electrical safety for the uh, preventive maintenance is one time per year, and when we the repair and we do the verification of the medical device is always do the after the repair after the verification.
Okay, ค่ะ So I think that this the answer from the speaker. So in the case if other participants you have the equations, you can ask directly to the speaker. I am not sure that in your country do you have the taste of this kind of tester available in your country, or you use another brand, or you can share.
Yes.
Miss Nabila, do you want to share something? Because I see that you unmuted your mic. Can we have your email address, Kun Saharat? I think that your email address is already available on the slide. I'm not sure. I will check. In the case if it's not on your slide, can you please type your email in the chat box? So I think that they will have something to contact you and some questions add on later.
Okay, I will type my email on the chat box.
Okay, no worry, Miss Nabila. We can understand because some of the participants they are on the working and some area is still very early in the morning, so that's why it's not convenient to turn on the microphone and directly chat. However, the chat box still available for you guys. Okay. So
Okay.
right now, Kun Saharat already share his email in the chat box. In the case if some of you guys have questions, so you can directly contact him via the email. So basically, for the calibration and verification of the medical devices. Right now, I would like to summarize like that we are following the guideline of the ECRI and also for the IEC standard. So that's why I'm not quite sure that in other country, do you have the same procedure or you have the different procedure? So could you please share to us?
Good morning, Prof.
Okay. Hi. Good morning, Amir.
Yeah. With regards to the first question to
Yes.
ask whether we have the testing tools. Um, well, from what I can say, 20 years ago when I started with the ministry, we
Mm-hmm.
used to have the simulators and the testing and the fluke meter. But
Mm-hmm.
now, since I left 13 years ago, I'm
Mm-hmm.
not really sure if they are still using the tools or the simulators or they've actually bought new ones. I'm not sure on the first question. And regarding the second question, whether we are following the standards, that one is a little bit tricky to answer since I'm not on the ground.
Mm-hmm.
Yes. What we do, we rely on our distributors, the
Mm-hmm.
suppliers, the vendors that are distributing or delivering the new machines to us.
Mm-hmm.
As now the annual or the service maintenance,
Mm-hmm.
it's also a little bit tricky to know what the people on the ground are doing.
Mm-hmm. Okay.
Thank you. Submit.
O- Okay. Thank you, Amir, for sharing. Amir is from Namibia, right? Am I right?
Yes, you are right.
Finally, after 10 days, I remember you. Okay. So we have the questions from the chat box. Okay, from Miss Nabila from Pakistan. She asked, "Can you please share the vendors dealing with the fluke medical and fluke medical in Pakistan? Because if we want to purchase type of
Oh,
calibration and monitoring, so we can contact them. So I'm not sure that they have the vendor in Pakistan or not. So can you please let us
oh,
know?
okay. I will check.
Okay.
Now I'm not sure in this distributor in Pakistan. I will ask for the headquarter first. I will let you
Mhm.
know.
Okay, he will ask the headquarter and then he gonna respond to you. And after he got the answer, maybe I gonna share the
Yes.
contact to you guys here because I think that some of the country right now you
Yes.
are in the process and then you need some of the calibrator device for your job or for your department. So okay, we're gonna provide the information later. Okay, the next question is from Mitipika from Mauritius.
Good morning.
Hi,
Good
good
morning.
morning. Good
Yeah.
morning.
I would like to ask if I can get help for using the electrosurgical analyzer from Fluke. I have one at office, and it is there from before I joined the department, and I don't have any training on how to use. If there is any video or the instructions how to use, it
Mm-hmm.
would be easy. Thank you.
Okay.
I will send the quick guide and instruction in English to Dr. Sunny, and I will send to
Mhm.
you.
Okay.
Yes,
Okay.
okay.
We're gonna pass the quick guide to you guys. And in a case, if you have some more questions, you can directly ask Kun Saharat in the email. And I'm not quite sure that do you have any distributor of Fluke in your country? Don't they provide the training for you guys after you purchasing that device?
Yeah, yeah, we have, but this one is purchased a long time back, and
Ah,
I don't know who supplied it,
okay.
and who should give the training to us.
Oh,
Okay.
from I think from Malaysia. From you, are you from Malaysia?
Yes, she's
Yes,
from
yes,
Mauritius.
Not from Malaysia. I think the distributor of fruit is the Belcom.
Mm-hmm. Okay,
okay.
so could you please to share her the information of the dealer in Mauritius? So in the case if the quick guide is not enough to setting up the machine or for the being used, so she can more contact for the
Sure,
the training
sure,
request the
sure,
training.
sure, sure.
But I'm not sure
Uh,
that
Yes,
if the machine already a long time ago after purchasing, they gonna provide the training or not.
okay, okay.
Yes. It's
Sure, sure.
always a problem.
Quick.
Okay.
Okay,
yeah.
okay.
Thank you.
Thank you very much, Kun Saharat. And we have
Yeah.
another question from where? Okay, from Ramsley. Okay, from Namibia. I have a few simulators, Fluke and Rigel at my workshop. And okay, I simply follow. Okay. So, okay, in Namibia, or Amir already share us about the situation of the calibration in your country. Okay, from Namibia, from uh Pakistan. Okay, from Nabila. One more question: can we get the training and learning from Fluke on the usage of this analyzer?
You can get this the how to use it, and for the video in the website, I will type the website of the Fruit Biomedical to the chat box.
Mm-hmm. Okay, you can firstly learn in the video because they normally have the video for the training. Because we have got one training from Fluke, but not seen more. Okay. So Kun Saharat right now, he
Okay.
typed the website of the flukemedical.com, and I think that you can figure out and seek for the training video. However, in the case if you maybe the video is not deep enough for your learning, maybe Kun Saharat gonna search for the distributor or dealer in Pakistan, and maybe you can make the request from them. And however, if they don't have the dealer in Pakistan, so maybe you can contact Kun Saharat and find a way for the training.
Okay.
I'm really
Sure,
not
sure,
sure
sure. Fine, fine.
about that. Okay, maybe you need to come to
Okay.
Pakistan for provide a training, huh? Okay, and I heard that
I,
Pakistan
I,
is very nice
I didn't
country.
saw with
Anyway,
this time.
yeah. Okay. So, do you have more questions? Hmm. So I think that it will
Prof,
meet
I have a
the
question.
okay. Okay.
I would
Please.
like to find out um, the calibration of the testing tools. Who
Mm.
does that? And how do they calibrate the testing tools and how often? Because I know we do simulate, we are simulating, okay, or we test our devices, medical equipment with the simulators and the testing tools, but then who is calibrating their testing tools? Just
Oh,
interested
for
to
in
know.
Thailand, we send back to the secondary lab.
So can you explain more about the secondary lab?
For the secondary lab is the they is they are organized have they are the organized to the trace back for the analyzer and the simulator for the to the SI unit for the secondary lab. And also you can send back to the manufacturing food biomedical.
Mhm. So how about in Thailand, who provide a secondary lab in Thailand, for example?
Yes.
So they can take a look in their country that if you have the secondary lab uh, to test the device for you.
Okay.
Mhm. Okay. Another comments in chat box from Sri Lanka. In Sri Lanka, we send fluke machine to India to calibration. Yeah, you can do that because India is the big market for medical devices, and I'm for sure that they're gonna have the secondary lab in India. Mhm. However, in Namibia, when maybe we need to take a look if it's not provided in your country, maybe the country nearby, you have contact, and maybe you need to send the device to calibrate it in the nearby country. We will take a look for you, right? Kun Saharat, you can take a look for them because they are in Namibia, and I'm not really not sure about that. Okay, thank you for sharing, Mr. Amal. Okay, any more questions? So how often for the Rook machine need to be calibrated annually? Is it annually or uh, how often?
Uh, for in Thailand is annually one time per
Annually.
year.
Okay, one time per year in Thailand. But as I told
Yes.
you in your
Yes.
in different country, maybe you have the different guideline to follow. But as in Thailand, we follow for our standards and the international guidelines. So they request for annually calibration. uh, any more questions? Or you can share. I'm not sure that how many participants that are together with me right now. Okay, let me check. Uh, I want to know the situation in Ecuador because right now we have the participant from Ecuador, Mr. Franklin. How's the situation of the calibration and verification of the medical devices in Ecuador? Did you do by yourself in the hospital or you have another third party to do it for you? Are you there? Okay. Normally, they don't do by
Oh,
yourself. Okay. Do you have the third party have the contracts to do it for you? Okay. Thank you for sharing. And how about
thank
in
you, thank you.
Tanzania? How about in Tanzania? Mr. Motojo, are you here? How about the calibration and verification of medical devices in your country? Did you do it by yourself or you do in like ask the contract or third party to make it for you? Oh, maybe he's not here. Okay, it's very interesting because right now we have the Bhutan team here. So from Bhutan, can you share us how about the in Bhutan Are you here? In Bhutan. Do you do the calibration of the medical device by yourself, or you use the third party or the subcontract to do it for you? Mr. Doji, I think that I see you here and also another Bhutan's team here. Okay, maybe they are at work or in the, on the way to work, because I think that Bhutan is like follow the time is follow us for 3 hours. Okay. So in the case if other participants have the questions, so please feel free to ask. Okay. In the case if you don't have the questions right now, you always ask and type it in the WhatsApp group. And then after that, we're going to collect all of the questions and ask directly to our speaker, or you can ask him directly by the email that he typed it for you. And I'm for sure that Kun Saharat, you're going to get some of the many emails later on from our fans. Okay. 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 Okay, in the case if you don't have any more questions, I think that on the morning session, I think that it will be finished, and I would like to thank you a lot from TREATMED and Kun Saharat to give us the special lecture for today. And in the case again, if you have the questions, please feel free to ask him. And thank a lot for all of participants, and thank you very much for Kun Saharat and TREATMED team. Thank you very much.
Thank you very much.